Madhu sir.
Yes, sir. Tell me, sir. You joined.
Is it audible, sir?
Yes, sir. Yes, sir. 100% audible.
Is it audible, sir?
Yes, sir. Yes, sir. Audible, sir. Fine. It's very audible.
Can I share my PPT, sir?
No, 1 minute, sir. We will share
16,
the thing. First, we will have an introduction, then we'll share, sir.
Okay, okay.
How many people join?
It is opening. It is opening.
Yes, sir.
No, no. First time I have to connect it. I have to as a host. Then it will start hosting. Then after that it will open the system.
And
Madam, another 5 minutes left.
A very good afternoon to all of you. I heartily welcome all of you in the afternoon session of our first day of 5-day webinar on NBA and NAAC accreditation process. Before we start the session, we have some announcements for the participants. For the link about the session, please keep checking your mails under the tab Updates and Promotion of Gmail. Also, there will be poll about the session at the end. So I request all the participants to be there till the poll ends there. Now I will take the privilege to introduce our next speaker of the afternoon session, Dr. S. Karthikeyan. Dr. S. Karthikeyan has obtained his bachelor degree from Coimbatore Institute of Technology, Bharatiya University, and master's degree in the industrial engineering from the Tyagarajar College of Engineering, Madurai, Kamaraj University, Madurai. He has obtained his diploma in industrial safety with industrial safety from Annamalai University, and he completed his PhD degree from Anna University, Chennai in 2009. His area of interest in research is quality improvement in engineering education, and he is presently working as an associate professor in mechanical engineering and associate dean in the Tyagaraja College of Engineering. He is one of the resource person for MBA outcome-based accreditation and education New Delhi. And he has 18 years of teaching experience guiding PhD and PG students on quality engineering and management. He has been awarded as a certified lead auditor from NQA, Germany, and he received the gold medal for implementation of ISO 9001-2000 certification at Tyagarajar College of Engineering, Madurai. He has carried out an extensive research work on the above area and published many good publication technical papers in the national and international journals and conferences. Now I would like to request Dr. Karthikeyan to deliver his talk. Sir, we welcome you in the session, and please, I request you to please start the session.
Thank you, Kalpana madam. It's a nice introduction about me. Thank you. Is it audible?
Yes, sir, it is audible. You can start.
Okay. So, good afternoon to everybody. First of all, I would like to thank the management of MS Ramaiah Institute of Technology, Principal, and Professor Madhu for inviting me as a guest speaker for this webinar on National Board of Accreditation and NAAC accreditation during these pandemic situations like COVID-19. So morning, we had a wonderful session in the inaugural. Dr. Dilip has explained what are the importance and the mobility of the graduate engineers in India and abroad. And also Professor Madhu has explained in the morning session the overview of the outcome-based education and related process like vision, mission, program educational objectives, program outcomes, and the continuing of this outcome-based educations. Now I am going to talk about curriculum design and development in engineering education systems, right? Shall we share, sir?
Yes, sir.
Is it visible?
It's loading, sir. It will take time. Yeah, it's visible, sir. Yeah. Sir, you please keep the full screen of the presentation.
Yes, 1 second. Is it okay?
Yes, sir. It's fine now.
Some right side screen is available here. Okay.
Sir, you please continue now. Yeah.
Yes, thank you.
Okay,
Now
sir.
I am going to talk about curriculum design and development in engineering education systems. Normally, this curriculum design and development process or changes are applicable for university and autonomous colleges, that is called Tier 1 institutions. And the affiliated colleges are adopted the curriculum, whatever the university has given and implemented. These are all the normal situation in India, that Tier 1 is autonomous and university, Tier 2 called as a affiliated to university system. Now in the Tier 2 colleges, it is very difficult to implement and change the curriculum development and the design. It's in the systematic manner, because it is a very difficult situation for the affiliated to university systems. But
Sir, I will request you to please switch on the video also, sir. Your video.
which one, ma'am?
Yeah. Participants are all requesting for the video also.
Asking video.
Your video also. They want to see you also. So just click on the video, sir. Your video is there. Yeah. Thank you,
Okay.
sir. Yeah. Thank you, sir. Yeah, we can see.
Okay. So normally it is very difficult to implement the curriculum design and development in the Tier 2 cities, but they have to identify the content beyond the syllabus and teach them to their students, like a guest lecture or a seminar or some organizing conferences or international events or hackathon, maybe identify the current trends of the curriculum design and development. Now we are talking about webinar outcomes. So at the end of this webinar, the participant will be able to understand the basic concepts of curriculum design and development and scheduling of courses through special interest group model. And final outcome should be prepare the design document for each course, because the outcome-based educations, we are expecting outcomes. The same thing at the end of this webinar, the participant will be able to the following things like understanding, scheduling, and prepare the design documents. Now, what are the expectations of internal stakeholders, for example, students and parents? So after entering the engineering colleges, most of the students are is the college is getting, I'm getting the job in engineering colleges. The parents are asking, my son is getting the job. So these are all the expectations from the students and the parents. Some students are whether we have to complete the graduates or our degrees, sir. So these kind of questions may be asked from the internal stakeholders. So these are all the some of the outcome of the students and the parents from the engineering. They are expecting from the engineering colleges: graduation, placement in core and allied areas, and research laboratories, and higher education in reputed institutes like national and international level. And another outcome is entrepreneur, startup, or incubator. These are all the expectations of the students and the parents. Now, what are the expectations of external stakeholders like industry, government, and society? All the external stakeholders are expecting the employees should have professional knowledge, professional skills, and attitude and behavior. So these are all the expectations of the industry and government and also society. Now, what is professional skill? Professional skill, professional knowledge is a graduate engineer outcome. At the end of the graduate, the graduate will be able to following this professional knowledge. For example, factual knowledge, conceptual knowledge, procedural knowledge, metacognitive knowledge. Factual knowledge means it's a remember type, and the conceptual means understand type, procedural means apply type, metacognitive means thinking knowledge has been improved from the engineering colleges side. And professional skills means whether this graduate has been explained or demonstrate or communication skills and leadership or management skills has been improved from the colleges. So these are all the expectations from the external stakeholders. Now, as an engineering college, we are the manufacturer in between these two stakeholders of external and the stakeholders of internal. Now we are going to produce the graduate with the expectations of the industry or a government and society. So for that, we have to change the need of the hour. So that is morning, our professor Madhu has explained a lot of ideas about output-based model into the outcome-based model. So this is the need of the hour in engineering colleges and the university systems. What is outcome-based education and assessment means? Now, whether we have to achieve the outcome of the graduate attributes, that is the outcome. Now, earlier system input and output-based assessment, it's only numbers. For example, number of placement, number of publications, number of students placed in core company, number of students gone to career studies. These are all called as an input and output model. For example, if you are planting a tree, mango tree in my home, so I am putting water and something. Daily I am pouring that organic fertilizers. These are all the input material I am giving to the tree. One day, one fine morning, the tree is giving 100 mangoes. So that is called input and output based assessment. 100 mangoes, that's all. So now we are happy on that 100 mangoes are available in my tree. This is one of the best example of input and output based assessment model. But now what is the outcome based model? The mangoes, we have received the 100 mangoes. All the mangoes are going to market to sell in the market. How many mangoes are purchased from the customers or stakeholders? For example, the mangoes are taste, mangoes are very full, colorful color. These are all the outcome. Not only the numbers, it should be have the taste, color, and other features are called as a outcome. Now, the same kind of things are called as a outcome-based education. Whether our graduates should have a knowledge like a taste, or skill, and the behavior of the graduate is expected from attain the just completion of the program after 4 to 5 years of graduation from our organizations. So this is a shift from output-based model to outcome-based model. So this is an overview of the outcome-based educations. Morning, Madhu sir has explained about the program educational objectives, program outcomes. For this session, we are going to see about the curriculum and the scheduling of courses and the topics CDIO model, cognitive levels, courses, total number of credits, distribution and curriculum gap, courses and the PO metrics, course map, then course design, course outcomes, competencies like mapping with the cognitive levels, competency map and the concept map has to be discussed in this session. Then finally, content delivery is a teaching and learning method. So this session, we are not focusing on content delivery. Then assessment. Finally, continuous improvement. So this is the overview of the outcome-based education. Morning session, Madhu sir has completed the first two. The second session, we are going to complete curriculum and the scheduling of the courses and the course design. Now, already morning Madhu sir explained about what is PEO, what is program outcomes and the course outcomes. I am talk about course outcomes in these sessions. Now, this is the OBE framework. The left-hand side blue color shows the outcomes of our program. The middle level curriculum planning and delivery, curriculum, content delivery and syllabus systems, delivering system, teaching and learning system in the middle side. Right hand side, the assessment evaluation is a test 1, test 2, program assessment, institutional assessment. Finally, we will get improvement through feedback of graduate exit survey, employer survey, alumni feedback survey to improve our existing system to further systems. This is a OBE framework of the NBA. Now, before that OBE, we are going to understand that what is course, what is degree, what is program. The course is nothing but it is a unit of teaching or subject of study in the typical every semester in the college. Like for example, some students are taking some other subjects. It's a choice-based credit system course. So it is a subject of study, which subject the students is going to take in a semester, and moreover, the more faculty and fixed registered students for this particular course. Program means branch of engineering. Like the branch of engineering means, for example, Department of Mechanical Engineering having 2 more programs. For example, automobile engineering and metallurgy engineering, mechanical engineering. These are all the different programs of the particular Department of Mechanical Engineering. That each and every program have a different arrangement of courses and co-curricular and extracurricular activities to accomplish the predetermined objectives leading to the awarding of degree. Now, this is called program. Now, what is degree? Degree is nothing but BTech or BE or BR. These are all the examples of the course. What is course? Course means subjects of study. That is course code and course name. 14 ME 630. Quality engineering is a course name. Program is civil engineering, mechanical engineering, electrical and electronics engineering, electronics and communication engineering, computer science engineering, IT, etc. Degree is BE, BTech or BR. Now, morning, Madhu sir explained about the overview of the process flow of outcome-based assessment. Now, in this session, we are going to see about OBC, outcome-based curriculum. Now, what is curriculum? Curriculum is defined as the courses offered by a school or a college or a university, but it's really used in the general sense of educational institutions. According to the Bell 1971 states that it is a socially valued knowledge, skills, and attitudes made available to students through a variety of arrangements during the study of school, college, and university. This is the statement of our definition of the curriculum courses. Now, how do you arrange these courses in the different manner? It's called the curriculum development process. In the curriculum development process, first identify the needs of the expectations of the society, expectations of the government, expectations of the industry or a company, and associated with the learning objectives should be identified. Then organization of the every content may be organized, and the determination of the accepted evidence of every learning materials. Then identification and development of learning experiences in the step 4. Then preliminary evaluation and pilot testing and outcome evaluation. Now we are going to see about the identification of the societal need and associated need learning objectives then organization of content, determination of the acceptable evidence of learning. So up to step 3, we are going to. Then learning experience and evaluation is assessment pattern. Finally, the outcome is evaluated through different manner. This is the process of curriculum development. Now, this is the steps involved in the curriculum development process. This is the input. The left-hand side is the input. The right-hand side, after assessing, the graduate will be graduated. So now what is the input? Gathering data from input factors. Learners. Who is learners? Student is a learner. Subject matter expert, it's called as an industry expert or a faculty expert. It's the input. Then resources like a man, machine. Then resource materials, societal trends, community characteristics, educational psychology and philosophies are the input factors. From the input factors, we are going to collect all the data for the drawing implications of curriculum design and development. After creating the curriculum design and the scheduling of the courses, now next we have to plan for each and every courses how to implement this teaching methodology in an innovative method like ICT tools or online courses or lecture scheduling, lesson plan, course plan should be implemented. In the implementing the plan, every plan should be analyzed through organized manner. It's called implementation. Planning, organizing, scheduling, then monitoring, controlling, everything should be implemented in the third stage. After implementing in the teaching learning processes, we have to assess each and every product as approved or not. That's why we have conducted the 3 internal tests and final terminal test we are conducting for the assessing the graduate. After graduate, we should collect the feedback from the each and every systems, because this is a closed loop system. Suppose we are not collecting the feedback, means it is an open loop system. So suppose we are collecting the feedback, means we are identify what are the needs are available from the stakeholders. So in the stakeholders, industries are giving feedback about, so your graduate after a PEO, for example, program educational objective, at the end of the graduation, after 4 years or to 5 years, the students will be able to design something or create something or demonstrate something. So at that time, we will get the feedback from these particular activities. Otherwise, we will not change the curriculum as it is we are going. So every year, we are conducting the Board of Studies meeting and Academic Council meeting to change the curriculum in a different manner because of technological trends and Vision 2030 and conducting with SWOT analysis for curriculum development changes. Now, this is the source of content. These are all the pillars of the curriculum development. First one, lecturers. Second, subject matter expert. Third, external examiners, employers, accreditation bodies, politicians, Institute of Higher Learning people, and students, academic advisors, professional bodies, alumni, graduates, government policies, academicians, comparison and benchmarking. So each and every content is called as a pillars of the curriculum development, because lecturers are giving feedback about the particular course. Then subject matter experts are giving feedback about the particular course. During the examination, external examiner giving the feedback. During the placement time, employers are giving feedback. Accreditation bodies are giving the feedback during the NBA visit or NAAC visit. Politicians are giving feedback about engineering education system is good or not good. Institution of higher learning like IIT, NIT people are giving feedback about the subjects. And the students are giving, because students is a main pillar of the curriculum and the courses. The students is giving, this subject is very good, this subject is needs to improvement. These are all the suggestions have may be taken from the students also. Then academic board giving the advice to the curriculum development. Then professional bodies like Association of Mechanical Engineering and so many bodies are available. We can get the feedback from the professional bodies also. And main thing, the alumni will give the feedback about the graduates of the institutions. And the government policy has changed during 2018, government policy has changed the curriculum development in the different manner. Then academicians is given the feedback about the curriculum development. Then comparison and benchmarking, worldwide benchmarking should be done at curriculum development, because we need to, our product is going to world international level, because after getting the accreditation, our graduate will be entering, it's allowable to work as an engineer or any higher studies, they are eligible to study or work in foreign countries because of accreditations. So, as earlier told, government policy, now our AICTE has revised our UG curriculum. Our chairman of AICTE, Professor Anil and Saraswara Buddhe, has given the message about the revised model of UG curriculum in engineering has been designed, where the number of credits have been reduced to 160 credits. Earlier it was 164, before that 200 credits are available. But now from 2018 onwards, the revised model of AICTE UGC curriculum has introduced to 160 credits. Now the total number of credits are 160, and also they are given the distribution of the courses, like basic sciences 21 credits, humanities and social sciences 8 credits, engineering sciences 21 credits, the professional course 62 credits, program electives 33 credits, project 15 credits. These are all the mandatory from the AICTE. So based on these AICTE mandatory credits, we should implement the scheduling of courses in the each and every program of the engineering colleges. For example, mechanical engineering curriculum should have the following. This is the mechanical engineering scheduling of courses from first semester to 8th semester. So before starting the 18, this is 18 regulation courses. Before starting the 18 regulations, first of all, we should identify all the courses of the 18 regulations from first semester to second semester, 8th semester, up to 8th semester. We have to identify all the courses. It should be aligned with the AICTE mandatory courses also, but it should not exceed with 160 credits. Likewise, we have to arrange that 160 credits for this particular course. This scheduling of courses is the heart of the outcome-based education. Without scheduling of courses, we cannot do anything. We cannot produce graduates as per the knowledge or a skill, attitude, anything. So the courses is very, very important in the every engineering colleges like autonomous or university systems. This is the most, this is an overview picture of the program as defined by the AICTE. Then it is the most important portion of OBE also. In this schedule, all the courses are identified as per the AICTE norms. No changes in the courses. So AICTE has defined these courses as most important courses. For example, the mandatory courses are identified in the right-hand side. For example, mandatory audit courses, right? Audit courses are environmental science, Constitution of India, then essence of Indian knowledge. These are all the mandatory audit courses given by the AICTE. Now, most of the courses are in the different colors. The different colors are basic sciences, 21 credits, then humanity sciences, 8 credits, engineering sciences, 21 credits, design, 18 credits, manufacturing, 20 credits, thermal, 15 credits, industrial engineering, 9 credits, electives, 36 credits, project 15. Totally 160 credits are identified for the mechanical engineering systems. So each color, for example, yellow color has explained about the electives of the mechanical engineering. So for the electives, the AICTE is not given the elective subjects. So these elective subjects which enable the technological trends of the society and also the industrial expectations and the Vision 3030, and also we will conduct the SWOT analysis of what are the subjects are needed in the present situation. It's identified through these electives, because all the necessary components like a design, manufacturing, thermal and industrial engineering, they will not change as per the AICTE norms, because AICTE norms is fixed. So we have to change the courses from the different electives. That's why we have developed a one model called special interest group model. This model is invented and developed by Tyagaraja College of Engineering in the year 2008. Now we have implemented this model in very good manner. Now we are getting a very good results also. And every year we are changing the curriculum and the development process is going on in a systematic manner as per the Board of Studies meeting, as per the Academic Council meeting. Everything is going on very well because of special interest group model. What is this model? So this model is called special interest group model. The group of people are working together with their interest. For example, faculty, staff, and the student member, it's a group member. So for this model, first we will identify the department vision and the mission. Earlier, Madhu sir said the institute vision and the mission, and the PEO. For the PEO is the program, right? The Department of Mechanical Engineering is a program. First, you identify the Department of Mechanical Engineering vision, then mission. Then you should identify the theme area of the department. What is theme area? The theme area is a recent development of mechanical engineering is to be identified through like program educational objectives. You collect all the feedback from the stakeholders. For example, alumni or industry, government, then students, faculty, then internal stakeholders like a parent. You should collect all the feedback and conduct SWOT analysis for identifying the theme area. Then after identifying the theme areas, you should identify the sub areas of the theme area. The theme area should achieve the department vision and the mission. Likewise, it should be the synergized manner of to attain the program educational objectives and the program outcomes. After identifying the sub areas, the group of people are working together for teaching learning purpose and research and development activities and industry institute interaction activities. Finally, we will get excellence in engineering education. This model has been developed in 2008. Now we are implementing this model in Tyagaraja College of Engineering. Now, what are the theme areas and SIGs at our college? Department Civil Engineering, its theme area is eco-friendly structures. Now, the special interest group of civil engineering is steel structures, concrete structures, soils and roads, environmental engineering, water resources, solid waste management. Likewise, computer science, distributed computing, and a database management system, mechanical engineering, automation, vision systems, supply chain management, quality engineering, thermal engineering, design engineering, manufacturing engineering. All the people are under automation. It's a sub area, theme area. These are all the sub areas. Then electrical and electronics engineer, power system and energy is the theme area. Then sub areas are power system, power electronics and devices, digital control, soft computing, instrumentation, and energy studies. For electronics and communication engineering, wireless technologies, radio frequency system, digital signal processing, VLSI, image processing, networking, embedded system. These are all the these are all the various theme areas of every department and also every program. We should, after identification of the sub areas, so we are focusing for this into teaching learning process. There are three concepts. One is teaching learning, another one is research and development, the last one industry institute. Now we are going to implement this SIG model into teaching learning process. This teaching learning process, first we should identify the theme area, sub areas, and the special interest group, then faculty and the student membership. Now we are entering into the teaching learning area of the process. There are two areas in teaching. One is teaching, another one is learning. In the teaching, there are so many critical factors are available for teaching. For example, subjects handling through SIG based.
Excel sheet ಅಲ್ಲಿ already ಇದೆ ಅಲ್ವಾ ಅದು, ಈಗ no change ಅಂತ ಇದೆ.
Yeah, sir. Okay. So many critical factors are available in the subjects in the teaching. For example, subjects handling, it's a SIG based, case study based teaching, interdisciplinary approach, guest lecture and seminar, classroom management, project guidance, educational tool and motivation to the students is a critical factor for teaching. For example, learning, problem based learning, group and cooperative and collaborative learning, hands-on and experience and learning, then interactive lectures, learning styles, and diversity in learners, learner-centric approach. These are all the learning factors. Now, these are all the different factors are available in the teaching learning process. One is educational system, second curriculum development, education support and assessment, library, faculty development. So in this SIG teaching learning process, we are focusing on curriculum development areas. Now in the curriculum development areas, curriculum development, syllabus formation and revision, SIG based subject allocation, SIG based course plan and lecture notes, courseware, tutorials, and invited lectures based on SIG, beyond the syllabus SIG based, asynchronous learner centric. These are all the things are identified through this teaching learning concepts. Now, what is the outcome of this model is innovative teaching, design capability, and product development, research orientation. These are all the outcome of this SIG teaching learning model. Finally, we would get quality graduates of this particular SIG model. Now, these are all the critical success factors of the teaching and the learning factors: design document, case study, interdisciplinary, guest lecture, classroom management, project guidance, educational tool, and motivation. These are all the learning process. Now we will take the example of one department called Electronics and Communication Engineering Department. The sub areas of Electronics and Communication Engineering Department, it's called Radio Frequency Group. This group may be implemented this teaching critical factors and the learning critical factors. First, we will see the teaching critical factors. The first critical factors for design document and subjects handling SIG based. Faculty belonging to RF group will identify the courses, prepare the design document, and handle the subject that belong to RF group only, and its sub areas like electromagnetic fields, microwave circuits, antennas, RF system. Likewise, they have to identify the sub areas of this particular group and identify the experts to deliver the lecture. Then case study based teaching. So RF face the real-time specifications of shifter and mixers were taught in the case study based. Then interdisciplinary approach. Any new development in the antenna related to RF is suitably changing the material used for fabrication. So that material science teachers were requested to educate the students on material characterization. The guest lecture seminar for only radio frequency group. So for example, Bharati Bhatt ma'am from IIT Delhi frequently visited our lab for the improvement and innovation ideas has been implemented through guest lecture and the seminar. Then classroom management, few of the concepts were handled in the RF lab in research center, and the live demos on vector network analyzer was given. Project guidance also in the given by the focused area like Motorola, and measurement in villages like were carried out with the help of the students. Educational tool and in-plant training should be focused on this RF group. 3 RF industries in Bangalore and local base station antenna manufacturer visited by our industry. This is one group example of special interest group of EC department in the college. The motivation to the students, alumni of RF group were made to talk to the present students. These are only one of the initiatives we have taken for this particular group. Now, these are all the various groups of EC department. Now, we are going to how the curriculum of EC has been developed in the different manner in the future slides. So, RF specialization, it's mapping with the PEO3. Baseband processing specialization, it's mapping with the PEO3. VLSI, PEO1, embedded system, PEO1 and PEO4, image processing, PEO4, computer networks, PEO2 and 4. This group consists of faculty members, PhD scholars, PG students, and the UG student. The UG student called the 4th year student, 3rd year student, and the 2nd year student. Because 1st year students are general papers, they are going to study about the physics, chemistry, mathematics. In the 2nd year onwards, the students entering into the a department or a program. So at that time, the second year onwards, we are giving orientation about special interest groups. So immediately the second year students are joining in the special interest group in a focused manner. The innovative idea of this model is like a doctor model. Now all the doctors are called as a specialized doctor. For example, ortho doctors, for example, cardiologist doctor. Likewise, our engineer, our graduate should be called as a RF engineer, baseband engineer, embedded system engineer, or a computer network engineer. So likewise, we have to synergize our area into the focused manner. So the second year students are entering into this group is called, the next slide will explain about what is the explanation of the special interest group means. First, ECE student, the theme area is wireless. The SIGs are formed sub-areas, RF, image processing, digital signal processing, VLSI, and so on. Now, each and every sub-areas of wireless technologies of ECE department have each and lab, every lab, IP lab, DSP lab, VLSI, medical electronics lab, remote sensing lab, embedded lab. Each and every lab should have some SIG members called as a faculty members and a research scholar, PG and UG students. So the UGs, for example, faculty members are doing the research work in the area of RF side. Immediately that work will be splitted into this research scholar. The research scholar will split the work into the PG scholar. The PG scholar distribute the work to UG final year students. The UG final year students split the work into third year students. The third year students split diverse the work into second year students. Second year students are the learning initial learning period. The third year students are capable of doing many projects. The final year UG students are capable of doing final year project. Then PG students are capable of doing very big project. Then the PG students are the research scholar students are capable of doing the research analysis. Finally, the faculty is doing lot of work in this related RF area. Likewise, every group has defined each or every activities made on this special interest group model. So based on this, every teacher has to, every group of ECE department has to identify that curricular gaps shall be carried out in the following way. The feedback from the class committee, course committee, and the student exit survey for the particular group, RF group, image processing group, they should collect the feedback from the class committee, course committee, student exit survey, employer feedback survey, and the feedback from alumni through only the particular group of RF group or image processing group. Feedback from the industrial expert related to the RF industry, related to the remote sensing, related to the image processing. The GATE syllabus are also identified for the curricular gaps. Then after identifying or after receiving the feedback, the RF group has identified some core subjects and elective subjects of this particular group. For example, radio frequency group identify the linear networks, electromagnetic field theory, and antennas, wave propagation, microwave engineering, wireless engineering, circuits lab, image processing lab. These are all the core area of radio frequency group. Then electives are called as antennas, wireless communications, radio frequency. Likewise, every group has identified core and elective subjects in the prescribed manner. For example, image processing, network, embedded systems, then new courses introduced. Apart from this group, each and every group has identified the new courses to introduce the meet PEO1, because PEO1 is after at the end of the graduation, our fourth year or fifth year, our graduate will be capable of doing the following things. These are all the recent development of the wireless technologies. For example, core courses, designing of PLDs and FPGAs, mixed signal circuits. For example, elective courses, advanced signal processing, advanced digital processing, then real-time operating systems, and digital video systems, satellite image analysis, satellite remote sensing. These are all the courses are identified from the different groups of people. Then same thing, new courses introduced to meet PO2, high performance communication, digital signal processing, and MIMO wireless for communication systems, satellite remote sensing. These are all the PO3 and PO4. Now, apart from these additional new courses has been introduced, we are identified the uh, uh, gap for the curriculum. It's through industrial persons or higher learning institute persons. We are conducting 1 credit course for the each and every group. Now, what is mean by 1 credit course means 1 credit courses or syllabuses are framed by only industry experts or higher learning institutes like IIT or IAC or NIT people how to design this 1 credit course syllabus. Then they are going to take the classes in only Saturdays, Sundays. In Saturdays 7 hours and Sundays 7 hours, totally 14 hours for 1 credit courses. And also 2 credit courses may be given to students by industrial experts and higher learning institutes. 2 credit course means there are 2 14 hours. For example, 1 Saturday, Sunday and second Saturday, Sunday, second level of Saturday, Sundays. Totally 28 hours has to be taken for 2 credit course. So likewise, we have to identify the bridge the gap of the 1 credit courses and the 2 credit courses by the industry supported persons. So for example, global positioning system, Mr. T. Ganesan, Texas Instruments, Bangalore has given the 1 credit course, and the VLSI implementation and communication transceivers, Sundarajan, Texas Instruments, Bangalore has given, and the high-speed signaling, Professor Madhavan Swaminathan from Georgia Institute of Technology, USA has given the 1 credit course at our college, and systems engineering, Mr. Madan Mohan, Honeywell Technology Solutions Limited, Madurai has given the 1 credit course. So each and every department have a theme area, every theme area have a sub area, every sub area has to identify the industry supported courses and higher learning institute supported courses for during Saturdays and Sundays. So after identifying all the courses, like scheduling of courses for, this is for electronics and communication engineering department, each and every color combination has different SIGs of the department. So now what is the impact of this model? For the faculty, curriculum development has been changed frequently, and the scheduling of courses may be changed from frequent, and course design has been changed frequent. The faculty has updated knowledge about the changes of the curriculum and innovative ideas, innovative technologies, recent technologies, and Vision 3030, and also so many industrial feedback. So the faculty has expertise in the technological trends. Now the students aspect, expertise in focused area like RF, job in, they will get the job in core company, then they will get the higher studies in the core areas, then they have to identify the idea to product, and synergized research leads to patent. In our college, so many students have filed a patent because of this model. So almost we got 3 US patent, and Indian patents are so many Indian patents are available. And the infrastructure aspect of this model is we have incubated a company called Tyagaraja Telecom Solutions Limited and the Makerspace. This is only because of RF group, the radio frequency group, final, the idea to product, the student idea to product has incubated a company. Now the customers of the TTSL is DRDO, ISRO, Motorola, Samsung, Siemens are the customers of the TTS. And one more infrastructure is Makerspace. It is a Makerspace is a 24/7 product development lab. Any student can come to Makerspace room. They can develop the, they can identify the idea and innovate the idea, and finally they will produce a prototype or a product into the different manner because of this model. Inter-department, it's a hackathon may be conducted. Inter-college national level event may be conducted through with the help of IIT with a specialized manner. For example, RF group is conducting collaboration with IIT and NIT. They are conducting the RF national event in the specialized manner. Now this is the model. SIG model is we are focusing on only internal level. Next we are going to focusing on national level and international level. So how many people are for example, RF group is working in the different area, means the RF group should identify the national and international level expert for this particular curriculum change and development and the scheduling of courses and the course design and 1 credit courses and 2 credited courses from the international level. We are thinking about that. This is the next level of our SIG model. Now, this is a course design. Now we are going to see about what is the course design. The course design, now we have identified all the 160 credit courses. After identifying the course, now we are going to identify the course content, course objectives, course outcomes, assessment pattern, then a prerequisite of the course, and what are the concept maps are available in the course design that should be needed for the prepare the course design. So every course must meet the requirement of NBA in every course must meet the requirement of NBA for engineering graduate through knowledge, attitude and behavior and skill. So morning, our Professor Madhu has explained about a lot of things about program outcomes. Before the program outcomes, now what is the difference between ITI, diploma and BE? Now ITI is capable of, ITI graduates are capable of doing or solving the structured problem. But diploma students are capable of, are able to solve the problem in a semi-structured. But our engineering graduates are capable of doing unstructured and complex engineering problems. For example, in my home, my fan is repaired. My fan is not working. I call ITI people. Immediately, ITI people, sir, put the switch and take some model and material. That problem is solved. For the diploma student, semi-structured problem. Sir, our rotor is not working, sir. This is the kind of diploma holder statement. But our BE student statement is, sir, current voltage, everything is okay, but fan is not working. We should implement the Hooke's law for this particular problem. We should implement this algorithm for this particular problem. That type of thinking should be implemented in the complex engineering problem and unstructured manner. This is the difference between ITI, diploma and engineering graduates. Now morning, our Madhu sir has explained program outcomes. The first one is engineering knowledge. As per the Washington Accord, in India, NBA has fixed the program outcomes. We don't change the program outcomes. So whatever the NBA has given, that is a program outcome. We should implement into the different programs. So in the program outcomes, first program outcome is engineering knowledge. In the engineering knowledge, see the program outcomes wordings from the National Board of Accreditation. Apply knowledge of mathematics, science, engineering fundamentals, and an engineering specialization to the solution of complex engineering problems, not a structured engineering problems, not a unstructured, not a semi-structured problems. It should be a complex engineering problem, because our engineering graduates are capable of apply the knowledge of mathematics, science, engineering fundamentals, and engineering specialization to solve the complex engineering problem through knowledge level. Then second program outcomes, problem analysis, identify, formulate, research literature and analyze complex engineering problems, reaching the sustainable conclusions. It's like a knowledge. Then third, design and development of solutions, design solutions for complex engineering problems. So every program outcome says a complex engineering problem. So it should be a knowledge level of program outcomes. Then conduct investigation of complex problems, conduct investigation of complex problems through using research-based knowledge and research methods, including design of experiments, analysis and interpretation of data, and the synthesis of information to provide a valid conclusion. These 4 program outcomes are especially for knowledge. The fifth outcome is modern tool usage. Create, select, and study appropriate techniques, resources, and modern engineering and IT tools, including the prediction and modeling to the complex engineering problems. So, with an understanding of limitation, it should be a knowledge and also skill. So, because the students are going to use the modern tool usage like a software tool or a coding tool or experienced learning may be tested in the modern tool usage at laboratories or product development lab or makerspace lab, 24/7 lab. They are going to use the modern tool usage with the knowledge and the skill. Then 6th one, the engineer and society apply the reasoning informed by the contextual knowledge, and this should be a skill and attitude. And the 7th one, environment and sustainability. This is also skill level of the program outcomes. The ethics, apply the ethical principles and commit to professional ethics. It's attitude. Then 9th outcome is individual and teamwork. In the individual and teamwork, function effectively as an individual or member or leader in the diverse teams. And then on multidisciplinary settings, it is called as a skill and attitude of program outcomes. 10th outcome is communication. It is one of the skill level of program outcome. Then project management and finance, the skill, and it may be a knowledge, skill, and attitude. And the final outcome is lifelong learning. Recognize the need of the individual and the ability to engage the independent and lifelong learning in the broadest context of technological change. This is a skill and attitude. These are all the program outcomes defined by the National Board of Accreditation with respect to Washington Accord. Now, based on these program outcomes, what is the process involved in the improving of the each and every courses in the curriculum? First, we have to identify the course objectives. After identifying the subject name or course name, the first step, you should identify the course objectives, then enabling objectives, then content of the syllabus, content of the particular course. This is called syllabus, content or module of the what to teach in the syllabus. Then teaching methodology, how to teach. It may be a classroom teaching or online teaching or ICT2 teaching. Then finally, after teaching, the evaluation. If the evaluation is met with the COs, definitely we will stop. Suppose if not, reviewed by academic committee or board of studies meeting, again, we will change the course objective. What the students should do or know, what the teacher should do, and comparing what the students have to learn and what the teachers taught. These important factors should be analyzed in the academic council meeting, reviewed by the all the people like top level people in the academic committee meeting. So this is the changing or improving the course and the curriculum in the different manner with the help of Bloom's taxonomy. Bloom's taxonomy is one of the method to measure the course outcome of outcome-based educations. In the Bloom's taxonomy, there are 6 levels of cognitive levels to measure the assessment of the course outcomes through remember, understand, apply, analyze, then evaluate and create. These are all the Bloom's taxonomy keywords or verbs to measure the outcomes of the every courses for the students' improvement. So this is the process involved in the improving the courses. Now, this is the entire course design structure of the every course. First, we should identify the course designer. Who are all going to design these subjects, design this course based on SIG. Already we have discussed about the SIG, mapping with the faculty expertise with the SIG. Then course structure. What are the points are available in the syllabus or course design? It's preamble, prerequisite, course outcomes, mapping with the POs versus CO, Bloom's taxonomy based assessment pattern, then course outcome level questions, concept map, identification of modules and submodules, syllabus content, and the text and the references, lecture schedule, session plan. These are all the design of course. This is the method of This method is implementing in our college in a systematic manner to prepare the design of courses. So now we can see step-by-step procedure for identifying the course. After identifying the course designer based on SIG, next step, we are going to design the document. What design? What do you mean by design document? The design document, it's an instructional design document. This design document gives the overview of your, is it visible, sir? Is it visible?
Yes, sir, it is. Yes, sir, visible.
Yes, sir. Thank you, sir. So the design documents should be in a different manner. Now, before preparing the courses, first we have to draw the design document in the prescribed manner. It's called, now, for example, we are going to design a content or syllabus for G45 machining practice. The terminal objectives or course objective is, first one, at the end of the program, a participant, at the end of the course, the participant will be able to explain the fundamentals of metal cutting and cutting tools. This is the terminal objectives. It is a course outcome. Now, enabling objectives to meet these terminal objectives. To meet the terminal objective, the enabling objectives are explain the basics of metal cutting. Then, to meet the enabling objectives of level 1, the enabling objectives level 2 have explained the principles of chip formation. So,
Sir.
Sir, tell me, sir.
Sir, the design document is not open actually.
Which one, sir?
Document design is only there.
So you have to share the documents.
Is it visible or?
No, it's only the document design is there.
No Excel sheet?
No Excel sheet, sir.
One second. Now, sir?
Your screen. Then?
Now it is okay?
No. It is initial first PPT is there.
Show your place, sir.
Show Excel sheet. Sir, reduce it and then open the Excel sheet, sir.
I opened the Excel sheet, sir. I opened the Excel sheet, sir. Is it visible?
I think it stop. Sir, you stop sharing and then open the Excel sheet.
Okay.
Share screen, sir.
Yeah, now it is visible.
Okay.
Yeah.
Okay, so let us take example of mechanical engineering subject machining process G45. First, we should identify the terminal objectives of the particular subject. So at the end of this, sir, tell me, sir.
Sir, enlarge the screen.
Oh. Okay.
Yeah, correct. Yeah.
This is the design document for machining process for G45 courses.
Make the Excel sheet little bit bigger, sir.
Okay.
Yeah,
okay,
fine, sir, fine.
Okay. So this is the design document for machining process G45 course. First, we should identify the terminal objectives of this particular course is. Now we are going to draw the course outcomes, right? At the end of the program or a course, the students will be able to explain the fundamentals of metal cutting and cutting tools. To meet the terminal objectives, we have a enabling objectives of level 1 is explain the basics of metal cutting. And to meet the enabling objectives level 1, we should write the enabling objectives of level 2. Explain the principles of chip formation. Likewise, we have to write each and every enabling objectives. And finally, we have to identify the content. So based on the objective, enabling objectives and the terminal objectives, we should identify the content of each objectives. the mechanism of cutting and chip formation. For example, orthogonal cutting model or chip thickness ratio velocity. This is an example of this particular course outcome content. Now, what is a methodology of assessment of this particular content is understand. In the Bloom's taxonomy, knowledge level, it's a understand. Cognitive level, it is a concept, not a factual, not a procedural, not a metacognitive. This is the concept level of understanding. So that's why this is a cognitive level is concept. So the methodology, how to teach, explain the principles of chip formation with the help of animation or videos or pictures or a PPT. So you should define how to teach the methodology in the for the particular course outcomes. Then what are the remarks in the course outcome, course objective is the textbooks or guidelines, manufacturing engineering technology, Surup and Kalpat Jain, and this book is essential for machining practices, and elements of workshop technology volume 2 is essential for this particular course outcome of this one. What is the timeline? 90 minutes for this particular course outcome. Evaluation, different types of question may be asked for this particular area. Define the chip thickness ratio. What is the orthogonal cutting? What is the state, the difference between orthogonal and oblique cutting? These are all the different evaluation techniques, question bank we have to prepare in the syllabus also. These are all the references and the logistics. So this is the sample document design for machining subject. So we first terminal objective is explain the fundamentals. Second terminal objective is explain the working principle. Likewise, each and every. So the main objective of the design document, first you should write the course outcome before identifying the content. From the course objective, you should identify the content. Earlier model, we have earlier model of course design and the curriculum development is we have taken the content from the book, textbook, immediately we put it into the syllabus book. So that is not needed in the outcome-based education. The outcome-based education gives a lot of information about how to morning Professor Madhu sir explained it is not a teacher-centric approach, it is a learner-centric approach. How the students are learning from these courses. Likewise, we have to identify the terminal objective 2, terminal objective 3, terminal objective 4, terminal objective 5, terminal objective 6. Minimum, each and every course should have the course objectives or course outcomes. 6 outcomes should be there in the syllabus. Even our autonomous college or university college or tier 2 colleges, after receiving the syllabus from the university, you should write the course outcome for this particular course is minimum 6 course outcomes should write for the every courses, like this type of manner. For example, to meet the enabling objective, to meet the terminal objective, to meet the enabling objective of level 1, what is the level objective of level 2. This kind of document should be prepared before preparing the content. From this objective, we should identify the content like this. After identifying the content, we should post it into the course design, right? So these are all the content of the machining process, right? Shall we move on to this? Sir, is it visible, sir?
Sir, visible.
Right? After preparing the course design, So the first one, so this is the entire structure of the course. First, we have to write the preamble. Second thing, we should write the prerequisite of the particular course. What is the prerequisite courses for conducting? What is the need of the hour to conduct this particular course? What are the prerequisite courses are available? That should be identified, right? For example, prerequisite for electrical people, AC machine E42 is the best example of prerequisite. This now we are going to design a document for AC machines E42. Now the overview of the AC machines, 3-phase induction machines, 3-phase synchronous machines, right? Now let us take example of from elementary school for the preliminary prerequisite courses. Course objective of the elementary school student is students will be able to multiply any given two numbers. The scopes, so suppose the students of third class students required to learn multiplication, what are the concepts students should be familiar? One is natural numbers, second one addition. Assume that natural numbers are taught in first standard, in addition to that taught in second standard. Now the course map linkage is the course outcome to learn the concepts of students will be able to multiply any given two numbers. They required to know the following concepts: natural numbers, addition, and the ability to count physical things. What are the prerequisite courses? Mathematics standard first standard, mathematics second standard, then science first standard. So likewise, we have to identify the engineering courses like this is the elementary school examples. The CO2 for the students will be able to divide the given number into given number of parts. It's a real number, subtraction, addition, multiplication, ability to count physical things, mathematics first standard. These are all the prerequisite courses for these course outcome and prerequisite courses. Now for the AC machines, the prerequisite courses for the conducting the AC machine is mathematics 1, mathematics 2, mathematics 3, and environment science 1. For example, we have to prepare the design document for AC machines. Course outcomes are explain the working principles of construction of the induction machines. The enabling objectives are enabling objectives level 1, explain the construction of 3-phase induction machine, explain the working principles of induction machine, explain the working principle at different configurations involved in the single phase induction machine. These are all the enabling objectives of level 1. Next level, enabling objectives of level 2, explain the construction of scroll cage induction machine, and explain the construction of slip ring induction machines. Now, what are the contents of this particular CO is explanation of on armature, rotor, stator, slip ring, and windings. So these are all the content of AC machines. Likewise, we have to identify 1.2 content and 1.3 content. Now, what are the linkages of previous semester to prepare the AC machines? The student must complete or studied AC machines. The prerequisite course for the AC machine is electrical material science. E25 should be studied in the before studying the AC machines. Now, the linkages to previous semester course, construction of scroll cage, slip ring, induction machines, explanation, everything is available. That the concepts and the methodology has identified and explained in the electrical material science. So to study the AC machines, the student must know the electrical material science. Likewise, we have to identify each and every courses of AC machines prerequisite course. Electromagnetism course, electric circuit analysis may be studied in the previous semester course. Now, what is the AC machines subjects course outcomes? What are the prerequisites of these particular courses? Now, the course outcomes of the AC machine is explain the working principle of induction machine construction. Now, these are all the requirement of the concepts at the knowledge level, and these are all the prerequisite courses for transformers and DC machines E33, electromagnetics E32, electrical material E25, electrical circuit E20. Likewise, this is the method. I am giving example of electrical. Likewise, each and every program should have a prerequisite courses of this particular every course, the particular courses. Likewise, you have to identify CO2. What are the prerequisite courses? Now we have to create a linkages of, because this is a scheduling of courses, we have to linkage of every courses. For example, the semester 4, the students are able to study the AC machines. Now, what are before studying that AC machine, how the students are studied in the previous semester? In this semester 1, physics, chemistry, basics of electrical and electronics engineering, electronics and communication engineering studied. Then semester 2, engineering mathematics, electric circuit analysis, electric material sciences are studied. Then semester 3, electric material, DC machine and transformer has. Now he is eligible to study the AC machines. And as a course designer, you should write what are the prerequisite courses for AC machine means. You should write electromagnetics, DC machines, electric material and electric circuit, mathematics 1, mathematics 2, physics, chemistry. These are all the prerequisite courses for AC machines. Likewise, you have to create an entire linkages of from first semester to 8th semester. So each and every color has a different SIG, special interest group of our college. Basic and engineering sciences have a different SIG group, and electrical engineering, electronics engineering groups are different colors. So now, after that, after prerequisite, the document design. Now, course structure, preamble is okay, prerequisite okay. Next level, course outcomes and mapping with the POs and the COs. Now we have identified all the course outcomes through document design. Now we are going to mapping with the program outcome versus CO. Right? So this is the mapping of course outcome versus program specific outcomes. So minimum 6 outcomes for 6 outcome is needed for every course. This is called 6 outcomes. Now the 6 outcomes are mapping with our program outcome and program specific outcome after PO12, PSO1, PSO2, PSO3. Now getting the linkages. For example, 1 means less weightage, 2 means less correlation, 2 means small, medium correlation, 3 means strong correlation for this course objectives, course outcomes. For example, for this particular course outcome, determining the forming forces for various metal forming process. When compared to PO1, it's a 3. PO1 it's called engineering knowledge. Engineering knowledge is applying the knowledge of engineering, mathematics, science, or implementing to solution given to the complex engineering problems. So the CO4 given the very good correlation for the particular PO1. PO1 is engineering knowledge. Likewise, you have to map with each and every program outcome with course outcomes. Next level, Bloom's taxonomy based assessment pattern should be implemented in the syllabus. Now, Bloom's taxonomy is it's a taxonomy which is used for assess the student whether the student has attained the course outcome in a perfect manner. How to measure the student's attainment level and the student's knowledge level, student skill level has to be measured through these Bloom's taxonomy. The Bloom's taxonomy is called as a remember, type, and understanding, applying, analyze, and evaluating, and creating is a Bloom levels verbs are implemented in the curriculum and courses. Now, in the syllabus, we have to implement each and every course. We should implement the Bloom's category of assessment pattern. For example, we are conducting test 1 means how much level of remember question you will ask, how much level of understand question you will ask for this particular course, how much level of apply level this particular level is applied for the test 1. So totally 100 marks. Then test 2, test 3, then end semester examination. For this particular course, the course designer give, this is 0, right? So this course designer or implemented the analyze level of question for this particular course, right? 20% weightage will be given to the analyze, right? Likewise, the course outcome should be prepared in the assessment pattern of this particular course, right? Now, the Bloom's taxonomy knowledge level dimensions are varied from one level to other level. For example, in the remember type, so many factual questions may be asked, so many conceptual questions may be asked, procedural question, metacognitive questions may be asked for the remember level. In the remember level, we are only asking about define, list, name, or any law can be asked. It's a factual. Conceptual means basic understanding. Procedural means write the procedure for these particular principles or something. Metacognitive is the evaluation and create. It's a higher levels of Bloom's thinking of thinking. It's called as a metacognitive. It is very difficult to attain the students in the course level. So next one is a course design. In this course design, after identifying all the content in the through design document, we have to write each and every document. For example, the concept map. Is it visible, sir?
Yes, visible.
Okay. The concept map called the open source software is available to create this concept map. This is called CMap tool. This CMap tool is used to modify the content in the different manner. So after identifying the each and every course objectives, enabling objectives, and enabling objectives level 2, we identified the content. That content should be reflected in the concept map. For example, first module, this is for industrial engineering subject, industrial engineering overview. This first module deals with the scope, objectives, application, IE methods, probability based methods, outcome prediction, logistic regression, and the Bayesian belief regression, multi-criteria decision making, analytic hierarchy process, ANP, graph theory. So likewise, you have to put it in the concept map. This concept map is a very good summative idea of delivering the content or syllabus into the for the students in the first class itself. Suppose if you are going to class, the students must know what are the contents are available in the subject. Means the teacher will explain about through the concept map. These are all the concept map, right? After identifying the concept map, this is a simple examples of our college syllabus. The quality engineering is a syllabus course name, right? Now we have identified course code, course name, category of this course is program core, lecture 2, tutorial 0, practical 0, the credit is 2. Now the structure is preamble, then prerequisite for this particular course is statistical techniques. Then course outcome is on the successful completion of the course, the students will be able to CO1, CO2, CO3. So the course designer has asked at the apply level, the Bloom's apply level of the Bloom's. Next mapping with the program outcome. All the COs with mapping with the program outcome and the PSOs, program specific outcomes of the department of the program. Next assessment pattern of the quality engineering is remember, understand, and apply. So here the course designer has given weightage for understand and apply 40% and 40%, 20% for remember type. These are the sample course level assessment questions. Course outcome 1. What are all the questions? Already we prepared in the design document. Once design document are prepared, the course design is very easy. So this subject is passed in Board of Studies meeting 2016, then approved in 53rd Academic Council meeting 2016. Likewise, next concept map of this quality engineering. There are 3 modules: introduction, process control, and acceptance sampling of this particular quality engineering. And the next, these are all the syllabus which are all the covered in the concept map. All the definitions and the courses are defined in the syllabuses. No deviation from concept map to and the syllabus. Now these are all the textbook and the reference books of these particular quality engineer. Next, lesson plan. Lesson plan, course content and the lecture schedule should be like this: module number, topic, number of lectures. Then these are all the course designers. So this is a sample syllabus of Tyagaraja College of Engineering. It's a syllabus, right? Now, earlier model, it's a teacher-centric model of introduction of courses based on the only expertise of faculty, and the contents, the syllabus content is taken from the book, and observation is length of syllabus. Question paper, it's called as a describe or explain essay type questions, but no participation, no industry participation, and whether our graduate or role-ready engineer for the future, it is a question mark for the teacher-centric approach. But the outcome-based model has given the learner-centric approach. It's given the lot of ideas about the syllabus content, concept map, cognitive levels. The instructional design methodology is followed. That is called design document. Instructional design methodology is called design document. So participation of industry lead to produce a role-ready engineers, project management. The background of the students are analyzed. Bridge courses are conducted for filling the gap. 1 credit courses are identified. Additional elective, general elective has been identified because of learner-centric approach. Now, this is the classroom teaching. Already every colleges has maintained design document and creative thinking, behavioral aspect, IDM workshop, Mission 10X, NPTEL, IUCE, online courses, everything all the colleges are conducting. Then practical courses, it is a very difficult to measure the shifting the process to product orientation. Now, the RF group, because of RF group, incubated a company because of practical work. The Tyagaraja Telecom Solution Company has built from the practical work, because they have built a, they have produced a product for the society. For example, our customers, ISRO, DRDO, RCA Hyderabad, so many people, Motorola, for testing the antenna, they are coming to Tyagaraja College of Engineering for the only because of the practical course, shifting from process to product orientation. So we are conducting pre-lab, bridge lab, in-lab, and post-lab of activities in the practical sessions. Next, assignment should be problems and group assignments, mini projects, seminars are given to the students, tutorials, 2 groups per class, and teaching assistant, ME, PhD scholars may be used to conduct the tutorials. Then project, we have wonderful innovative ideas implemented in the project. We have implemented the project of progress diary, specific review mechanism, project and industries projects at institute, interdisciplinary project, engineering students with the science faculty may be implemented for the project incubation, project preparation. Now, what are the gaps and the challenges of these SIG model or these curriculum design? Only the question setting on higher level is very critical, because higher levels are on apply and evaluate and create. Whether our graduate has attained the level of higher level blooms, no. Question from reference book is very difficult, because we are taking only from textbooks. Reference books question paper is needed for this taking the question setting. Then assessment focusing on only on cognitive level. In the syllabus also, we are only measuring the cognitive level of remember, understand, apply, analyze, evaluate, and create. But we are not focusing on skill level and attitude, behavior level, because our program outcomes are only 4 outcomes is attaining the knowledge level. Remaining outcomes are skill and affective domain. So these are all the some challenges are in the current learner-centric approaches systems, in the less weightages are given to the psychometric and affective domain. Now, preparation of the question bank is very difficult. Then we should implement the effective midterm review and the lecture material preparation, automation of assignments and materials, and the performance measures through CO. These are all the behavioral aspects. It's a challenge of this course design and something. So for autonomous and university system, we can immediately change the syllabus. For tier 2 colleges, they should identify the content beyond the syllabus through different manner. They should identify the professional bodies of the student chapter at various level to organize the conferences, industry-institute interaction programs, workshops, seminars, and invited talks. And also they should identify the RN courses for the students for content beyond the syllabus to bridge the curriculum gap. And seminars and projects in the final year to acquire the knowledge beyond the syllabus. QEEE classes may be conducted for these students. Technical festival may be conducted. Industrial visit and support students to do the projects, NPTEL, Coursera, and finally the international conferences, national service scheme. This national service scheme shall help the students to take up socially relevant. Now, United Nations has given a lot of projects to through Sustainable Development Goals, SDG. So 17 problems are given by the United Nations. All the problems are solved by only national service scheme of our college, because they have identified the socially relevant problem, then identified and give the solution for the rural people. That is one of the initiative to identify the content beyond the syllabus. And also the students shall be encouraged to publish in-house technical magazine and newsletter or national and international level of the journals. So these are all the content beyond the syllabus for the tier 2 cities to identify the new content in the curriculum. In our college, we have implemented the new initiatives and the best practices to improve the curriculum development and design. We have implemented the collaborative educational program with the help of TVS Motors. That's why the TVS Motor gives this building worth to 15 crore worth of building, including all the equipments, machineries, labors, giving to give the research potential for the students in Tyagaraja College of Engineering. Not only Tyagaraja, South India people can utilize this facility in a systematic manner. This is a wonderful opportunities to visit TSS. The building name is called TSS CAR, TS Srinivasan Center for Automotive Research. That building was inaugurated by Srinivasan, the chairman of TVS Motors. That TVS Motor people involved in the curriculum design and development. Each and every course of mechanical and electrical engineering curriculum should have the subject matter expert from TVS Motors, because they have a signed MOU for especially curriculum development, curriculum design and development of through CEP model, collaborative educational programming model. For this particular model, they are giving placement for the first year students. So every year, every student, they got the placement at the final year. But the TVS program, they are giving the placement to the first year of mechanical engineering and electrical engineering based on the 10th mark, 12th mark, and first semester mark of engineering side. They are giving first year placement, and also they are giving industrial visit for all the students, not only the placed students, all the students of mechanical and electrical engineering. Internship during summer and winter vacation, 100% placement assured in the core company. Then guest lecture and seminars from TVS Motor has given frequently for the each and every courses, like 1 credit courses, 2 credit courses. So next initiative we have taken for the attainment of program outcomes. So the earlier model only focused on knowledge level, but this model is complete attainment of program outcomes from program outcome 1 to 12. The CDIO model has a very good model to implement to attain the program outcomes in a systematic manner. What is CDIO model? CDIO model is a model which is consist of conceive, design, implement, and operate. Conceive means student requires a higher degree of structure and guidance. Design means students work with less lecture or less structure, guidance, supervisions. And implement means student works with independently and within provided guidelines. And operate means student works innovatively with limited guidelines. So this model as implemented in Tyagaraja College of Engineering in 2018 onwards. There are separate association is available for this CDIO association worldwide. The Massachusetts Institute of Technology Professor Crawley has identified this model, invented this model in 2001, and also one second. So this is a CDIO syllabus, a statement of goals for undergraduate engineering education. Edward Crawley, Department of Aeronautics and Astronautics, Massachusetts Institute of Technology, invented and developed the model in January 2001. So in this model, all the...
Sir, Excel sheet is not visible.
Not Excel sheet, PDF.
Oh, PDF is not visible.
Okay, sorry. Is it okay, sir?
Yes, sir.
Is it visible, sir?
Yes, visible.
So this CDIO syllabus is only for undergraduate engineering education, not for PG program. This model is developed by Edward Crawley, Department of Aeronautics and Astronautics, Massachusetts Institute of Technology in January 2001. He has invented and developed a model for attainment of all the program outcome in a systematic manner. To attainment of skills and attitude, behavior, everything is covered in this new CDIO syllabus. The definition of the CDIO is graduating engineers should be able to conceive, design, implement, operate complex value, here the word complex value-ordered engineering systems in modern team-based environment. This is the definition of the CDIO. Now see the CDIO standards. This is the standards of CDIO. There are 4 classifications of the CDIO model. First one is technical knowledge and reasoning. Second, personal and professional skills. Third one, interpersonal skills. Fourth one, CDIO. So these 4 core area of CDIO is explained in the different manner it's called. For example, the first one is technical knowledge and reasoning. What are the technical knowledge are available in the CDIO syllabus is, first one is scientific knowledge, core engineering fundamentals, and advanced engineering fundamentals. This is same like a AICTE curriculum, UG curriculum. But we are lacking in these skills and attitude. So this is the same like CDIO and AICTE curriculum is same, scientific knowledge, core engineering, advanced engineering materials. But what about the skills? What is part 2? These are all the standards of CDIO. The first standard, technical knowledge and reasoning. The second, personal and professional skills and attributes. These are all the various sub areas of CDIO syllabus. Engineering reasoning and problem solving, and experimentation and knowledge discovery, system thinking, 2.3 system thinking, 2.4 personal skills and attributes, 2.5 professional skills and attributes. Then 3 is the interpersonal skills, teamwork and communication. You can see all the program outcomes are attained in the 1, 2, 3, 4 through CDIO model. For example, 4.1 external and social context. In our program outcome, what is the number? 6th number is environment and sustainability or society. and engineer and society. These are all the content are elaborated in the CDIO model. External and societal context. 4.2 enterprises and business context. Then 4.3 onwards, the CDIO system has been evolved. 4.3 and 4.4, 4.5, 4.6. The idea of the CDIO model is, first we will start from 4.6 operating. Now we should take the survey from the society side. What are the systems? What are the products? What are the processes are operating in a very good manner? What are the changes are needed? That should be identified through 4.6 operating procedures. In the operating, designing and optimizing the operations. So this is called reverse engineering. Reverse engineering, we should identify from the customer feedback to design. Now the same thing, CDIO is first 4.6 operating, then we should develop the conceiving. The second step, conceive. Conceive means, okay, now the for example, in the automobile, what are the innovative ideas are available in the automobile? What are the new technologies are improved in the automobile sectors? BS4 to BS6. BS6 is the now operating condition. Now, what are the limitations and the challenges of BS6? That should be identified in 4.6 operating. Then you have to conceive and design for changes for BS6. And after identifying the designing, you should implement the novel design. Then you can operate the new design. This is called conceive, engineering, systems design. This model is called CDIO model. So every model should be this is called second model, professional and personal skills. Likewise 3. This is 4. See the mapping of this particular course outcome. The right hand side, A, B, C, D, E are AICTE accreditation outcomes. For our, we can put the program outcome 1 to 12 and the PSO, PSO1, PSO2, and CDIO syllabus subsection. You should write 1.1, 1.2, 1.3, 2.1. You should write all the CDIO sub-content subsection of the CDIO syllabus. Now you have to merge with your content and the syllabus for the meeting of. Now we have to meet all the, for example, system thinking, experimentation of knowledge, professional skills and attitudes, teamwork, external and societal context. PO6 is attained. Enterprises and business contact, designing, implementing, all the PO should be attained through because of CDIO model. Okay. So next example. So this is ABBOT criteria. Likewise, NBA we will put NBA criteria in the different Boeing criteria. All over the country, every country has implemented this CDIO model. The last 2 years, Singapore Polytechnic has implemented this CDIO model, and Vietnam engineering colleges has implemented this model. Now, slowly it comes to India. In India, there are 2 colleges has signed a member of this CDIO association. One is Vailtech University in Chennai, and Tyagaraja College of Engineering, Madurai has a member of this CDIO associations. That's why now we are implementing the CDIO syllabus in 18 regulations onwards. So now the 18 regulations, the students are learning. 1 second. Is it visible, sir?
Yes, sir. Visible.
This CDIO syllabus. Okay. So
CDIO syllabus no.
No,
only
the
PDF
PPT.
is there.
PPT?
No. You have to stop sharing, sir.
Oh, stop sharing.
First stop sharing, then give the PDF.
Okay, okay. Okay.
Yeah.
So So we have started the CDIO syllabus in 2018 onwards. Now we have prepared the curriculum design and development through CDIO concept only. We have introduced the few courses based on CDIO. Further courses as per the mandatory of AICTE, audited courses is there, and compulsory courses is there. Only few courses are introduced through CDIO courses. First semester, we have introduced engineering exploration. Second semester, lateral thinking. Third semester, design thinking. Fourth semester, project management. Fifth semester, capstone design project. Sixth semester, engineering design project. Seventh semester, system thinking courses. So eighth semester, project. Almost this is like a project-oriented courses. So in the project work only gives all the program outcomes attainment through project work. You can see communication, teamwork, individual learning, ethics, engineering knowledge, problem solving, conducting investigation. Everything should be analyzed through project only. The earlier system of our curriculum design is the students are only doing the project at the 8th semester only. Now we have shifted the CDIO syllabus concept. The first semester onwards, they are ready to prepare the project. Engineering exploration is one of the subject, but in the engineering exploration, no terminal examination. There will be a presentation by the student. The students will be presented the applications of different engineering. For example, applications, and this particular application, this engineering may be applied to that level, this level. Okay. That type of presentation should be implemented in engineering application, in engineering exploration. Exploration means application-oriented presentation. Then lateral thinking in the second semester, they are thinking about application. Sir, I have one idea. We have to change this idea. The idea generation through lateral thinking. This is called second semester. Then design thinking, it's a mini project. Almost a prototype. They have to produce the prototype in the third semester. In the project management, fourth semester, all the cost involvement, project management, because our PO, program outcome 11 is a project management and finance. So the project management and finance will satisfy the program outcome 11. So the project management defines how to identify, how to prepare the Gantt chart for the particular project, and what are the activities are maintained in the project, and what are the cost involvement, what are the resources involvement, resource leveling, resource smoothing, resource crossing. Everything should be analyzed in the project management. Finally, they have to identify the YAN value management, how much cost are involved in the particular project. That should be presented by the fourth semester student. Capstone design project is one of the project. It should be included in the whatever you have taught in the up to fourth semester. We have conducted the objective type questions for the multiple choice question or objective type questions for engineering services examination. Like kind of test has been conducted for capstone. And also the fifth semester, the student must do the design project through FMEA analysis or failure mode effective analysis or voice of customer analysis or QFD analysis. They have to present it in the capstone project. Then engineering design project in the sixth semester is, for example, every group member or group or image processing group, they are focusing on design project. And finally, the seventh semester, entire system thinking project. System means from raw material to finished product. What are the resources? What are the components? What are the materials? What are the costs has been involved in the system? Finally, they are familiar in doing the project work at the 8th semester in TCE or in-house or in industry. So normally, all the students are going to project at 8th semester only in intern. So these are only CDIO based courses in the TCE. So this is the sample CDIO theory course template. Earlier we have seen the quality engineering course. Now we have shifted into CDIO syllabus. The syllabus content has changed. No, not at all changed. The assessment pattern of the syllabus is changed. Is it visible, sir?
No, sir.
Is it
So
visible,
stop
sir?
share and then, yes, it is visible now.
Okay. This is the, again, same process for the course design, course code, course name, category, lecture, tutorial, preamble, prerequisite, course outcome, everything is available. But in the assessment, we are including CO mapping with CDIO curriculum framework. Earlier, this table is not available. Right now, we have implemented this TC proficiency scale and CO1, CO6. What is the cognitive level? What is affective domain level? What is psychomotor level? Now, what is a curricular component? For example, CO1 1.1 achieved, 1.2. 1.1 means technical knowledge, 2 means professional skills, 3 means technical skills, personal skills, 4th means CDIO. Likewise, we have to write every number, CDIO curricular component number 1.1, 1.2, 1.3. So then as per the NBA requirements, we have to map with the PO1, PO2. So we have included here the CDIO learning domain level. So why we have included in the this cognitive and psychometric level, the assessment pattern, we are going to measure the cognitive domain through test and assignment. But assessment pattern of the psychomotor is not assigned in the previous syllabus. Here, now we are going to measure the psychomotor skill, mini project assignment. For example, we are giving assignment not in the cognitive level. We are giving in the psychomotor level. Do the project, do the something. These are all the psychomotor skills of different levels: perception, set, guide response, mechanism, complex over threat, adaptation, and origination. Right? This is the novel method we have implemented in the new curriculum. Others are same: concept map, syllabus, lectures, course designing, everything is same. This is for theory course. For the practical course, okay, is it visible, sir?
Yes, sir. Yes. Course template again you have to share.
Yes, sir. Is it visible, sir?
Yeah.
This is for a practical course. The same thing: preamble, prerequisite, course outcomes. Here we are mapping with the CDIO curriculum, cognitive and affective domain. Now, here assessment pattern, cognitive domain, model examination, remember, understand, apply, analyze, evaluation for the cognitive dimension. For psychomotor dimension, again, we have to psychomotor skills has to be measured in the program. So in the practical, we are going to measure the proficiency of cognitive, affective, psychomotor level. This is K1, K2, K3 level. This is A1, A2, A3 level, and this is psychomotor P1, P2, P3 skill. Sorry, S1, S2, S3 level. We are going to measure the TPS, Tyagaraja College of Engineering proficiency scale is available to measure the right, sir. So now it is okay. For more information about this model, visit www.cdio.org. Thank you for your kind attention. If you have any queries, kindly contact my number and through mail. Thank you, sir.
Sir, thank you very much, sir, for your informative presentation. Our panelists will ask few queries which people have raised.
Thank you, sir. Sir, a few participants have asked their queries in the chat that
Okay.
Dr. Jagannatham had asked that how R&D is useful for NAAC and NBA.
R&D means, so suppose the faculty should specialized in research and development activities, immediately the infrastructure and the facility has to be prepared through so many projects like a project proposals through the Government of India, Department of Science and Technology, and the AICTE has given a lot of money to each and every faculty members for the project proposal. Once the infrastructure and the facility has been implemented, immediately you can transform the novel ideas and novel machines, novel systems has been implemented in the curriculum. These are all the modern research and development technologies has been implemented in the curriculum design and development. Once you got all the machines, for example, in mechanical engineering, lathe earlier machine, old lathe is doing. Now all the people are doing 3D printing. Because of research and development, our faculty members received a lot of amount from industry and through consultancy and project proposals aligned with industry and college. Because of this research and development activities, the industry institute interaction relationship should be improved. Because of SIG, we are calling any function or a meeting, immediately we are calling only industry people. Industry people means allied or a antenna group of people will call for a meeting. Immediately the people will introduce the IIT people contacts. The IIT people give the contacts to international contacts. Immediately we'll get the overall relationship of every people will aligned with a systematic group like called as SIG group. This group gives ideas about that university is given a lot of proposal, lot of money, that company is giving a lot of money for this project. Immediately we will apply, we will get all the funds from the so many funding agencies, we can get the facilities. This facility is transformed into engineering curriculum.
Thank you, sir.
Thank you.
Sir, one more question is there.
Okay.
Dr. Heather Ali, he has asked that test 1, 2, 3 and terminal exams are used for direct evaluation. What about the assessment method like assignment, report, tutorial, etc.? And how can we adopt indirect assessment to achieve the course objectives? And what about the access of laboratories sources? How can we do that?
So in the course itself, now the current practice of every college is doing only the assessment only through cognitive level of assessment through Bloom's taxonomy. But not only the course design, the program outcomes are measured through different activities of the program, which will involve in the extracurricular activities, co-curricular activities, sports activities, that should be involved in the attainment of the program outcome. That should be measured. For example, all the students are involved in the extracurricular activities, co-curricular. Some people are expert in putting the journal. Some people are expert in these in NCC, NSS, sports. At that time, the people will have leadership skills, management skills that should be reflected in the attainment of program outcomes. But in the course level, course curriculum and design are only giving the knowledge level and the skill level, not affective domain or involved in the course outcome level.
Thank you, sir.
Thank you.
On behalf of our IQAC cell of NSRIT, I heartily thank you, sir, for this very informative and lively session. It was very interesting and useful for all of us.
Thank you, madam.
Now I request all the participants to take up the poll and give the feedback about the session. It is available on your screen. So please, all of you, poll this. And Separate links of the tomorrow's morning and afternoon session will be mailed to you by today evening. Please check your mails, and if you are not getting in inbox, please keep checking the mails under the tab updates and promotion.
Let it go, let it go, let it go. Hello, Karthik sir.
Yes, sir.
Yeah, very informative, sir. Very nice. Thank you very much.
Okay. Send me the feedback. Any
Yeah,
feedback?
we are
about
sending all the poll feedbacks, everything I'm sending, sir. Video also
Okay.
I'll share with you.
Okay, sir. Thank you, sir. Thank you.
Thank you very much, sir.
Thank you, sir. Thank you.
Now we'll end the meeting for all.
Okay. Okay. Thank you, sir. Thank you.
I end the meeting.